2.2, we're going to go over composition of functions. Again, everything in this section is review. We're going to review different notations. We're going to review the use of composition of functions. We're going to look at how I can look at a composition of functions in order to decompose the pieces that may have made it up, and then relate domain and range to the composite functions. So we're going to look at A and B here in this video. We might see how long this goes. So notations. Both of these are read as f of g of x. So f of g of x and f of g of x. And remember, whatever goes on the inside here is the first place that x gets plugged into. In this case, it's this term. That one, that's equation. So if I'm looking at two functions here, f of x equals 2x. This is under b. And g of x equals root x, and I want f of g of x, then I take x, I plug it in here, I take whatever is this as my output, and it becomes my new input here. So this quantity becomes, so if I was looking at f of x, it would have said f of x, and every time I see an x, I instead put in root x. So if we're going to do g of f of x, in this case, f of x becomes our first input, and so I'm going to have 2x plugged into the every time I see an x here, so this becomes root 2x. Sometimes they're looking for an evaluation versus just an expression, so g of f of 9. So I would plug in 9 for x into this one, and I would get g of f of 9 is root 2 times 9, which is just 3 root 2. Okay. If we want to decompose a function, this is the third goal, C, we're going to look at what may have made it up. We're going to say, well, this is made up of the square root of something and then a quantity 2x plus 7. So it's possible that I had like a root x and then a 2x plus 7 that made this up, because if I plugged this in for x, I would have got root 2x plus 7. Say I'm looking at this one, f of g of x. Well, what if this is 1 over some simple little x, and the x plus 3 was the quantity that got plugged in instead of our x. X plus 3. Okay. It's always possible that something could be made up of multiple compositions, so maybe this one is made up of like a f of x and a g of x and a t of x, something like that. So let's say I have f of x and g of x, and h of x is a good one. We'll call h of x. So let's say our very original function is x squared. Okay. And then here I take my x squared and I plug it in for x. Well, what would x have to be? X would have to be x plus 4. So then if I plugged in x squared here, it would then become x squared plus 4. And then I have g of h of x would be x squared plus 4. And then if I wanted it to be one more layer on top of that, I could do f of g of h of x, and that would be the cube root. That would make my third layer. So that means that I would have had to have plugged in this whole quantity for x, which means this needed to be the cube of x. So does that work? If I plug in this for this, I get x squared plus 4. If I plug in x squared plus 4 in for x, then I get the cube root of x squared plus 4. Cool, works. Our last goal is to talk about domain and range, which we've done so many times. We're practically blue in the face talking about it. So let's say I have something like this that's a linear function. Domain and range can be, here it's, the domain is from negative infinity to positive infinity. We're going to use the IB notation. And then here our domain is the same thing, negative infinity to positive infinity. Okay. And then if I took g of h of x, I would have 2 times x squared plus 3, which would give us 2x squared plus 6, right? So our domain wouldn't have changed from in our composition here. It would just be from negative infinity to positive infinity. So our domain here is still negative to positive. But there might be something different with our range. So here our range, any linear function that's, you know, nice and got a slope and a y-intercept, is going to look like this. Now here our range starts at our y-intercept of 3. So our range goes from 3 included up to positive infinity. But when we did our composition here, when we write this, our new vertex is going to be slid up to 6. So our new one is going to be skinnier and have a vertex of 6. So the range is not the same, so watch out for that. So 6 included. Oops, this guy up here should be the other way. Watch out for that. To positive infinity. That's a noisy piece of equipment in the background, isn't it? Okay. So let's say we plug into, we're going to look at a table here, x into h of x, and then we're going to take h of x, which is our new y, right? Our h of x becomes y, and then it becomes our new x. So everything in this column is going to get shifted over to become our new value. So -1 into h of x would give us, let's see, -1 squared is 1 plus 3 gives us 4. And then 0 squared plus 3 is 3, and then 1 is 4. And then now these become our new inputs. So 4, 3, 4. And then we're going to take g of h of x. So this is h of x is our new x inputted. So 2 times that would be 8, 6, 8. Here's sort of a different way of looking at this. So if I have an initial x value, it's our initial domain, right? And then that gets plugged into h, and h of x becomes our new range. Then here's the trick. This range becomes the domain, which goes in here, and we have our new range. So if we're talking about g of h of x, we can say that g of h of x, its domain, will be the same as the range of h of x, and then our final output will be our range.